Welcome back at BartlikBartlik YouTube channel for more construction basic knowledge. So please stay tuned by subscribing so that when you subscribe, YouTube will automatically notify you when we upload a new construction basic knowledge video. So today we are going to familiarize ourselves with the underwater construction. So the topic today is underwater construction, and we are going to define what underwater construction means, and also we are going to see the various methods that are used to do underwater construction. So let me just go straight to it to define what we mean by underwater construction. So underwater construction, it refers to a specialized field of engineering and construction activities that take place beneath the surface of bodies of water. So it includes a broad range of projects such as building pipelines, offshore platforms, tunnels, and marine ecosystems. So underwater construction refers to the process of building, repairing, or maintaining structure below the surface of water bodies. And these water bodies could be a lake, a river, an ocean, or even a sea. So underwater structures comes under a wide range of projects, including offshore oil rig and gas platforms. Also we have underwater pipeline, we have submarine cables, we could have a construction of underwater tunnels. Also bridges are constructed underwater or inside water. Also we have dams, we have marine research facilities, and many more. So those are some of the structures or activities that could be done underwater, or construction that could be done underwater. So let me just repeat it again for those who did not understand it well. The definition of underwater construction. Underwater construction, it refers to the process of building, repairing, or maintaining a structure below the surface of water bodies. I hope that is well understood. So we are just going to go again straight to the methods that enables engineers to carry construction underwater. So as you can imagine, doing construction underwater, you see it is a challenge because inside water the visibility is not that possible, the turbulence of water, it also poses a challenge. So basically working underwater, it's a challenge, but engineers have come up with ways to enable them to do construction underwater. So one method that is used to enable engineers to do construction underwater is called caissons. By doing caissons, so our illustration here shows what we mean by caisson. So imagine a massive watertight chamber that gradually descends to the ocean below. So setting the ground for a new building. This is how a caisson is constructed actually. So caissons are prefabricated steel or concrete. So a caisson, it is a prefabricated steel or concrete. It could be steel or concrete structure that is built onshore and then moved to the intended location. So it is built onshore, that is, it is prefabricated or it is constructed onshore, that is outside the water, and then now it is transported inside the water to the intended location or to the desired area of construction inside the water. So once this caisson is positioned, they are filled with concrete and gradually dipped into the ocean to provide a strong anchor to the seabed. So in another video we will show how this anchorage of the caisson is done on the bedrock of the sea. But for now we are just discussing the ways, or rather the methods, that enables engineers to carry out construction underwater. And I have just mentioned that one of the methods that engineers use is by using caissons, and we have said a caisson, it is a prefabricated steel or concrete that is constructed onshore, that is outside the water, and then transported inside the water to the desired area of construction inside the water. So when it is submerged, or rather when it is placed inside the water, it will displace the water and then provide the base for the construction. So in regions with soft or unstable soils, caissons are frequently employed to provide a stable foundation for coastal buildings like bridges and piers. So again, as you can see, this is the illustration of a caisson. So another method, or another type, or another methodology that engineers use to carry out construction inside water is by using cofferdams. Again, this is what we mean by a cofferdam. You can see how it looks like. So cofferdams, you can do a cofferdam, that is by driving sheet piles, and before you do a cofferdam, of course you'll have to drive a guide pier. You'll have to drive a guide pier to the intended area of construction, such that it will guide you up to the depth on which we have a safe bearing strata, or rather safe bearing ground inside the water. And also there is also another test that can be carried out by engineers to know at what depth in the sea we have the safe bearing capacity of the ground. It is called a penetration test. So this penetration test, there is a machine or a gadget that is dipped inside the water, and then it has a shaft that penetrates into the ground of the water. So with this, when it penetrates through a softer material, the speed of penetration is high. As it approaches a tough material or a rock material, the penetration reduces. Then it will signals you, or rather the value will tell you that now we are approaching, or rather we have approached a safe bearing capacity ground that can withstand the load of the structure inside the water. So we were talking of method number 2, which is cofferdam. So cofferdams are useful when the task at hand calls for establishing a dry working environment inside a body of water. Again, in our picture, that is what a cofferdam looks like. So to create a waterproof enclosure, sheet piles are pushed into the seabed to create these makeshift buildings, and construction can begin inside the dry space after the enclosure is sealed and the water is pumped out. So basically, you see, for a cofferdam, you have to drive, after you have driven a guide pile inside the water that is around the desired construction area, then now you'll come with your sheet piles, and then these sheet piles, you will drive them again around these guide piles. Remember, these sheet piles, they interlock. When they interlock, they reduce, or rather they minimize water from penetrating inside the area that is surrounded by the piles. Remember, for this activity to take place, we have a machine or a ship, a big ship called a barge. It's called a barge. So this ship will enable or will provide a platform on which equipments like cranes and excavators, backhoes, these construction machines. So the barge will provide that platform on which these machines can stand to carry out this activity. So for example, if you are driving your piles, if the piles are being driven inside the water, so you can imagine, where will this excavator, or rather the big machine, that a hammer machine or a hydraulic machine that will be driving the piles inside the bed of the sea, where will it be standing? It will be standing on top of a big ship called a barge. So this barge will be able to provide that platform on which this hydraulic hammer machine that will be driving the piles inside the rock, or inside the bedrock of the sea. So cofferdams, they are created by driving the sheet piles around the desired area of construction. So you'll have to do the first layer of the sheet pile, and then again now do the inner layer of the sheet pile. So you'll have 2 layers, and the space in between these 2 layers of these sheet piles, you'll have to fill with granular material, for example sand. So that is how a cofferdam is done. And remember that when you have done that, you will have now to dewater the water that now is inside the desired area of construction, such that you can create that dry area for the construction activity to take place. Again, look at our picture here. This is what a cofferdam is. And remember, this cofferdam can collapse because of the force of water outside. So for you to counter the force of water, or rather for engineers to counter the force of water outside from preventing the cofferdam from collapsing inside, then bracing is done, and this bracing has got ties and struts. They are bolted to the sides of the sheet piles such that they counter the force of the water that is outside, and then equilibrium force will be created. That is, the shafts, or rather the braces, the braces holding the piles, the sheet piles, and the force of the water outside. So it will be an equilibrium force, and then these cofferdam will be the cofferdam walls will be able to stand, and then construction activity can take place. But remember again, we could have a seepage. A seepage could occur in a cofferdam, because remember you have done the sheet piles, so we could have water coming from the bottom of the sheet piles, which is a seepage. So, and this seepage again could fill the inside of the cofferdam with water, which could also again hamper the construction activity. So what we do is you can do a concrete sealant. You can do a concrete sealant such that you seal now the spaces where the seepage could take place, and then now construction activity can begin. Remember again, for us to pour concrete into these places of construction, normally you see it is an area which is occupied by water. So we normally pour concrete using a machine called trimming. So this is what we call a trimming, and that is how it lowers concrete inside water. But again, in another video we will be discussing how a trimming works. But basically we are just trying to familiarize ourselves on how to create a dry area to do a construction activity that is in a water body mass, that is by doing a cofferdam. So cofferdam, that is another method. It's method number 2. So remember, first method we said is caisson, and I explained in the beginning, we explained what a caisson is and how caissons are done. So number 2 we have said it's a cofferdam, and I've shown you this is what a cofferdam looks like. Let's go to number 3. Number 3 is we can do construction underwater by using driven piles. Again, our illustration, you can see that is what we mean by driven piles. So driven piles are thin columns. Driven piles, they are normally thin columns driven into the sea floor by a vibrating or hydraulic drivers. It is just the same way you see the sheet piles to do a cofferdam. The way they are driven into the seabed is by using a vibratory or hydraulic drivers. So the same way these driven piles, that's how they are driven again to the sea floor. That is by using a vibratory or hydraulic drivers. And these vibratory or hydraulic drivers, these are just machines or equipments. And I've said for them to be able to carry out this activity, they are provided a platform on which they stand, and this platform, I've said, is just a big ship called a barge. So driven piles are thin columns driven into the seafloor by a vibratory or hydraulic drivers. They can be composed of steel, concrete or wood. They can be composed of steel, concrete or wood. So as you can see in our example here, these are our driven piles, and they are of steel. And again, you can see this another one is of concrete. So they anchor securely to the seabed and provide a foundation support for piers. So offshore platforms and bridges. So in locations with soft or unstable soils where conventional foundation techniques might not be sufficient, driven piles are especially useful. So they are an affordable option for underwater construction projects because of their reasonably quickly and easy installation process. So you see the installation process is just by using a vibratory or hydraulic drivers. So it is easy, no much activity needed. You just need the vibratory or hydraulic drivers to drive these piles inside water. And when they are driven, of course they will be driven until they reach a hard strata or a hard ground inside the water. And then again, let me show you what we mean by driven piles from the pictures. And then now let us go to the last option, which is off-site building, or you can also just say float and lower. Off-site building, float and lower. So off-site building, float and lower technique, this one, it involves constructing large components of a structure onshore. Onshore means outside the water, and then transporting them to the construction site via barge or other floating vessels. Remember, I've just described to you what a barge is. I've said it's just a big ship that provides the platform for the machinery and equipments to execute work while in water. So this offsite building or float, they are just constructed onshore and then transport them to the site via barge or other floating vessels. So after arriving at the location, cranes or other lifting equipment are used to safely lower the components into position. So this technique, it also minimizes the amount of work that must be done underwater, resulting in less expenses, reduced safety hazards, and lower impact. So you see, for this one, people don't have to go inside water to carry out that activity, unlike the one for the coffer dam, whereby you have to displace the water to create a dry area, and then people can go down to do that construction activity. So for this one, you just construct onshore, and then they are transported, and then they are placed on the desired area. But we will be, in our next video again, we will be actually elaborating on this offsite building or float, how it is done, because you can imagine a structure floating on water. You can imagine a structure floating on water, but it is done. So these are the 4 ways on which underwater construction can be done. Those are the 4 ways on which underwater construction can be done, or rather, these are the 4 methods on which enables underwater construction to take place. So let me just go through them by mentioning the names again. I've said number 1, we can do underwater construction by using caisson. Number 2, we can use coffer dam. So let me mention them as you also see the pictures on how they look like. So caisson, that is number 1. Number 2, we can use coffer dam. Number 3, we can use driven piles, and then number 4, we can just use float and lower or offsite building. Thank you, and please continue subscribing for more construction basic knowledge.